Hi guys, I'm back with another challenge problem. This time it's number 6, and we can see that on the left hand side we have a log function, a natural log of x plus y equals to 2 times x times y. And guys, we want to evaluate the derivative of y with respect to x at x equals to 0. Obviously we can again see that this is an implicit function where x's and y's are all mixed up together, so there's no reason for us to try to isolate y or eliminate y, or even try to get an explicit formula for y and then do the derivative. Guys, rather we are going to actually use the implicit differentiation technique, which starts with applying derivative on both sides and then trying to isolate the y prime or the dy over dx. So guys, we'll start with applying derivative on both sides. Applying derivative on both sides is d over dx of the ln of x plus y on the left hand side, and on the right hand side same thing, applying d over dx derivative on the right hand side 2xy. Guys, from here we have to recall what is the derivative of a natural log function. We know the derivative of a log function is the inverse function 1 over whatever is the inside the parentheses. So in this case it's going to be 1 over x plus y, but we cannot stop right here. We got to multiply by the derivative of the inner. In this case it's going to be d over dx of the inner. Inner is x plus y. So guys, I'm all still trying to write this in steps. If you are already very confident with doing the derivatives and you have solved so many different examples, then you can skip some steps and move on to the next step right away. Guys, on the right hand side, there's few things you can do. One of the things I'm going to do is I'm just going to take out that 2 outside. That's what we usually do with the constants when they are multiplied with other variables. And then it is just the d over dx of x times y. Keep in mind this is still a product of two functions, so in order to write this out one has to use the product property of the law of the derivatives. So guys, we got to treat this as f and this as g and use the product property, which I will do in the next step. From here guys, this is going to be 1 over x plus y in the denominator, and then in parentheses I'm going to get the derivative of x with respect to x is just 1, and then dy over dx. Instead of writing dy over dx, guys, how about if I write just y prime? Okay, that is on the left hand side. On the right hand side I will have a positive 2, and then I have to use the product rule. For product rule, first I have to find the derivative of f, which is 1 times just the g function, then plus derivative of the second function, which is just going to be y prime. We don't have an explicit formula for y. All we know is that y is a function of x. That's something we have to keep in mind. And then times the f function, which is the x function. Right, guys, we have all this, and all we need now is to evaluate the derivative of, find the y prime when x is equal to 0. So guys, there's few ways of doing it. One way is you isolate y prime. That's what we usually do when we have to use the implicit differentiation and then isolate or get y prime by itself. That's one way to go. Guys, the other thing is we don't try to actually isolate y prime right away. We go back in just this equation and substitute the values for x and y, whatever is already provided to us, and then from that this complex equation just simplifies to a simpler equation, and then at the end we can isolate or solve for y prime. Okay, that is my suggestion to you. Don't try to get the y prime by itself right here, because whenever guys we are evaluating for certain given points, then it makes sense to first substitute the values and then solve for y prime. Okay, so in order to go back and solve for y prime and substitute the given values, guys, I have my x value, so I can substitute the x value. But this equation I can already see, in this equation I can already see that I also need to substitute or fill in the values for y, but I don't have the value for y. Guys, in order to get the value for y, I may have to go back to the original equation, and in this equation I may have to substitute the x value, which is equal to 0, and from that I have to see if I can solve for the y variable. Most of the times, guys, when you see these type of equations, it would be much easier. It would be easier actually for us to solve for y just by substituting that value for x. So let us go ahead and try doing it here and see if it actually is easy for us to do that. Guys, this is going to be ln of x plus y equals to 2 times xy. I'm just rewriting this equation. If I substitute x equal to 0, so 0 plus y is just y on the left hand side. So on the left hand side I have ln of y. On the right hand side, if I substitute x to be 0, so 2 times 0 times y is just going to be 0. Guys, this is not such a difficult equation to solve for y. We know that the base here is e, and if we want to simplify or if we want to solve this log equation for y, all we have to do is that this y is equal to this exponent this base raised to the power, that whatever is on the right hand side. So it is e to the power 0. But what is any quantity raised to the power 0? Any quantity raised to the power 0 is just 1. That means my x and y coordinate points are 0 and 1. Okay, so it was not too difficult for us to get the y point. We have x and y. Let us go back and substitute the values. Guys, 1 over x is 0, y is 1. So 1 plus 0 is just 1. Then 1 plus y prime. Okay, this equals to 2 times, what is my y? My y is 1. So it's 1 times 1 is 1. Then x is 0. So 0 times y prime is 0. So that term is already vanished. So you can already see that by substituting the values for x and y, like this equation simplifies to a much easier and simpler. And now it is going to be much easier for us to actually solve for y prime. Now let us go ahead and try to solve for y prime. Guys, this is just 1. So it's going to be 1 plus y prime equals to 2 times 1 is just 2. If I have to solve this for y prime, all I have to do is I have to subtract 1 from both sides. So if I subtract 1 from both sides, I get 2 minus 1 is 1, and y prime is 1 is my final answer. I still want to make sure that this is what I have in my notes. Yeah, that's what I have in my notes. But if I have to write it in a proper notation, it is going to be y prime at x equal to 0 is 1. That is the final answer. Okay, so guys, this is example 6 in the challenge problem section. I'm going to show you one more example. So it's going to be 7 examples in the challenge problem section. And then guys, we're going to move into some other sections. Okay, till then, take care. See you next time.